Roswell Flight Test Crew here, back from the Norwescon 36 Science Fiction and Fantasy Convention in Seattle, Washington.
Here, I had a question. How do you run drone? Why did I tell you on UAV?
Alright, let's go to the videotape. Alright, so I hope everyone is here for transgender issues in a post-singularity. Sorry, it's my favorite con joke. Alright. No, this is own a drone, build and fly your own UAV. My name is Patrick Sherman.
I'm Brian Zawisna.
And together we are the Roswell Flight Test Crew. We started about 2 years ago, just sort of building our own little aerial camera platforms. All the aircraft we fly are multirotors. That is, they're helicopters with a minimum of 3 propellers. And this is a quadcopter. I'm certain anyone attending this conference can work out for themselves why we call it a quadcopter. Anyway, it's a 4-bladed helicopter, flies through the air, has a camera on it, transmits video. We're going to talk more about that later, so to avoid undermining our slide. Well, what I did here is I put together a general sheet to sort of broadly describe what these flying machines are capable of. And there's a lot of individual variation. Typical flying time is 7 to 15 minutes. That's before you have to land and put a new battery on. We carry a lot of batteries with us, so in a session like that day we spent with the firefighters, we would go through 10, 12 batteries, and we'd have them, cycling, charging off a car. Takeoff weight is generally between 3 and 6 pounds. You can build little itty-bitty guys that can accomplish the same basic function. The maximum proven airspeed of this one in particular is 40 miles per hour. Maximum altitude is probably quite a bit above 400 feet, but that's the limit set for us by the FAA. Maximum range for this type of system is about half a mile. However, people flying fixed-wing platforms have made like upwards of 35 miles now. Yeah. Multirotors are generally measured by nacelle span, which is from the tip of one motor to the tip of the other motor, and most of them are symmetrical like that. And they're usually measured in millimeters. This is, for example, a 450 quad. So you'll see like the S800 advertised. That 800 almost always refers to, it's an 800 millimeter span. So the very largest ones are about a meter, so being about 3 feet. And again, you'll see some ones if you stay around for the second session, which are, a couple of inches across. They're controlled occasionally on 433 megahertz, which is for long range operations, although the 2.4 gigahertz, just a standard hobby controller, is what most people use. And then we have a number of frequencies open to us for transmitting our video back from the aircraft to us. As I already mentioned, they're run off rechargeable lithium polymer batteries with anywhere between 2,200 and maybe upwards of 10,000 milliamp hours, running anywhere from 11 to 22 volts.
Now, the different frequencies, you said that 430 is for long distance?
Yes, it's a ham radio band. With a license, you can up the power, but then we get a longer distance.
Oh, so basically lower frequencies to give you a longer range?
Typically, it gives you better resistance to trees and objects and whatnot, but it's still line of sight, though. You don't want to be going behind object. But the 433 band is a ham band, though, so you've automatically got more power typically.
Okay, so this one's usually used in line of sight.
Oh yes.
Yeah.
Can you go behind? Drop behind a building to take a look or
no.
Something like that?
No. Well, I wouldn't try it. You might lose communication.
You can. What we do when we're flying is we refer to occlusion. We always work as a team. One guy's a spotter, the other one's acting as the pilot. And so the spotter's often calling off, okay, you're heading into light occlusion, meaning you're going behind a couple of trees. And this system's robust enough to tolerate that. But hard occlusion, a hill, a building, would probably, I wouldn't, there's some chance you might come out of it, but I don't think I'd personally take that chance.
Okay, so is the controller individually operated on like regular radio?
Yep, exactly like a normal radio controller. Sir?
What's the behavior when it loses signal?
The more sophisticated flight controllers will automatically take over. What they'll do is they'll automatically stop, they'll ascend it to 20 meters, they'll stop, then if they don't require, they'll come back home and land. Less sophisticated, they'll just drop. That's it.
Would the occlusion be an issue if I was pushing 20 watts on 433?
Probably not. If you could find a 20-watt hobby transmitter, the thing is, their video you have to beam back also.
Yeah.
So that may be, you may lose your video, but you still have control.
Keep in mind you need a ham radio license.
I have one.
There you go.
You said it goes to home after
signal.
Yes.
I think he wants to know how you set the waypoints for that.
Like, how do you set the waypoint
Oh,
for that?
built-in GPS. When you fire the craft up, it locks into home.
Essentially, there are two things you have to have: an aircraft capable of stable, controlled flight, and which is capable of transmitting video and telemetry, so you can get feedback from the aircraft. And then the second thing you need is a corresponding ground station, which can send control inputs to that aircraft and then receive the video and telemetry back. So it's really two separate systems that are working together, one for video and telemetry, one for aircraft flight and control. On the civilian hobbyist side, this technology is just advancing so amazingly fast. For example, I never considered that what I'm presenting to you now would have been true a year ago, that you can now essentially buy off the shelf the entire aircraft system ready to go. They haven't quite gotten there in terms of the video and telemetry yet, but I'm sure by the time we're giving this talk next year that will be the case. Well, first of all, if you choose to build, this is the inside of our larger aircraft, Raven. Looks like a computer vomited is basically the issue there. So in any event, so if you want to build one, watch our video last year online. Options, buy one. There are only a few right now, but my guess is by a year from now there are going to be a bunch more. So don't take this slide to be the end-all be-all catalog. But these two do sort of represent, the range of those which are commercially available. On the left we have the IdeaFly iFly 4, which all you get's the aircraft, so you need to provide your own controller, your own receiver to pick up the control signals and a battery.
$50 maybe.
Yeah, you could probably for another $100 have a basic flying system for that. So there's $320 and you're in the air. That's just an aircraft, no FPV capabilities. And it's got for as little as it costs, this whole aircraft costs as much as just the flight controller in this aircraft. And it does not a bad job. This has got a simple flight controller, no GPS, so bad things will ensue if it loses contact with the mothership, but not at all bad for the price. And then on the right is kind of the other end of the spectrum, the DJI Phantom, which is a extremely robust platform, comes with a built-in GPS capability, so it's got all that nice return to home functionality we were talking about earlier. It's got a mount for your GoPro camera already built into it. So very nice, and it comes with the transmitter, even a battery and a charger. So you buy that one for $679, you take it out of the box, you mount the propellers, you mount the undercarriage, and you're flying. And it's a very, very forgiving platform because of all that flight stability stuff built in. We're getting increasingly sophisticated flight control systems. A big one, which is sort of, if you're not doing this, is you don't necessarily appreciate how useful it is reliable altitude hold. That is, once you're flying along at 50 feet off the ground or whatever, the flight controller sort of wants you to stay there. And it accomplishes that by sort of, the throttle stick has got sort of a dead spot in the middle of it. Do you want to talk about how that works?
Well, essentially, with a real primitive flight controller, you're always going up or down. You're constantly adjusting your throttle to keep the thing in the air. The more advanced flight controllers take that out of your hands completely by maintaining their altitude, so you don't have to worry about that. Because if you're trying to fly the thing and you don't know if you're falling or going up, you can't tell where you are exactly, or it's hard to tell your distance from the ground if you're flying along pretty quick, as were the more sophisticated ones, of course, since they're holding your altitude more or less steady. It's just basically just easier to fly. So as they get
video too.
Yes,
absolutely.
exactly, a lot better video.
Absolutely.
As we can probably show you later on.
Yes. And then if you add the GPS capability, like the DJI Phantom, or the Phantom uses a flight control system called the DJI NASA, which has a GPS upgrade. You can buy those separately and mount them on whatever aircraft, or you can get the Phantom complete. So you've got that capability. But the GPS, which came out, 10 months ago.
Yeah, almost a year ago.
Yeah, it was after this, so. In any event, it's added some new functionality. We already touched on return to home. You flip a switch, or something terrible happens and you lose radio contact with your aircraft, and it just docilely floats home and makes a surprisingly good landing. And then the other thing this has given you the ability to do is have what some people call carefree flight mode, and you also see parenthetically IOC, which is Intelligent Orientation Control. It won't surprise you to learn that all model aircraft have a front and a back. And so if it's flying away from you, left on your sticks is left, right on your sticks is right. However, if you turn it around, you're flying towards yourself, all your controls are now reversed. Right is left, left is right. And so flying radio controlled aircraft, that's long been one of the big challenges, is learning how to effectively fly the plane backwards when it's coming at you, or the helicopter.
Well, also importantly, this is a big X. If you're flying it and it gets just barely out of visual range, you can't quite tell which way it's facing. So you can flip a switch and you pull back on your stick, it always comes towards you, no matter which way it's facing.
Carefree flight, that's carefree flight mode or intelligent orientation control. Basically decouples aircraft heading from direction. So pushing out on your stick is always away from you, pulling back is always towards you. It's going to cripple an entire generation of RC flyers.
It uses the GPS to figure out where it took off from, therefore where you are, and where it is, and it just orients it accordingly.
In order to have an FPV system, as I said earlier, you need to have components on the aircraft and on the ground. And so this is just sort of a brief rundown of those components on the aircraft. And here I'll hand it over to our technical.
What does FPV stand for?
Oh, excellent question. Thank you. FPV stands for first person view. That is this style of flying. That is, you view, the environment as if you are on board the aircraft, or in other words, from a first person perspective. So when you put the goggles on, you are seeing through the aircraft's eyes. So thank you. Great question.
Well, essentially there are three components to the video downlink. Of course, there's a camera. Then we have, secondly, a video transmitter, which is housed in the dome here. Ours has a small antenna out the back. So we're basically taking the video from one of these two cameras, through a video switch in our case, to then, and this is an OSD device, which provides our telemetry as far as GPS location, altitude, speed, battery condition, so we can see that our heads are displaying the goggles. Very important to have that. Then, of course, a video transmitter, and then on the ground station we have video receivers to receive the NTSC analog video that transmits, and we record on board with our GoPro camera typically, so the video is very high quality. The video downstream we receive isn't as high quality, but it's suitable to steer the craft around, and as you can see in some of the video.
And as it happens, oh yes sir.
On your slide there, you're saying a ham radio license is required.
Oh yes.
That's correct.
Unless you want to have very little bit of power. Basically what it is like 25 milliwatts is acceptable, but we run half a watt on this, so we can go a lot further. So you could definitely do it without a ham radio license, just not going very far.
Sir?
Using two cameras on there?
That's correct. We've got the GoPro, the ubiquitous sports camera, and then we've got just a little pinhole low light security camera. We have a switch on board, which is hooked up to a switch in our controller, so we can change from one camera to the other, basically as a backup system. The GoPro, yeah, they're both facing forward. Yeah, the idea is the same view. The GoPro has got its own battery, which is occasionally known to run dead. I mean, you should watch your battery level and not let that happen, but if it does, all we have to do is flip a switch and we're back in the game.
How many cameras can you run on that?
Well,
You have like one for aerial views and have one camera facing.
Oh yes.
yeah, you certainly could do that, and we occasionally have mounted probably as many as 4 on one aircraft at any given time to capture different views like that.
What about that one?
This has only got the 2. It's a smaller aircraft, and it would be a little bit heavily burdened if we put too many cameras on here, but it would work.
Could you like face the pro cam down and then
Oh yes,
fly
absolutely.
by the security camera?
Yep. As a matter of fact, we
Just
did
the other
that
day,
just
yes.
the other day. We were some folks had lost a very nice fixed-wing model airplane in a sort of overgrown place called the Jungle, and so we showed up and they asked us to help them look for their airplane. So that's exactly how we flew. Brian was at the sticks. He flew out using the low-light camera pointing forward, and then once he got over the target area, flipped over to the GoPro pointing down, and so sort of did a survey that way. No.
Ouch.
Yeah.
They gave them the video. They can look themselves in the video.
Frame by frame. Sir?
Any experimentation with digital?
Digital video?
Yes.
We have not yet. The thing about digital video is it's either all or nothing. There's not much in between. Analog video, you can have static, and if you can see a little bit through the static, you can still fly, but digital video, pixelation is not going to help anything, unfortunately. So not for our primary camera. We could certainly do a video downlink to a digital recorder, but not for our flight until either it becomes more reliable or it'll pass along something other than frozen frames.
Digital is trying to make things look nice by just freezing the frame or something, but there's nothing more harrowing than flying, your video's going all staticky, and then you just lose video. I mean, that's about the worst feeling you can have. Sir?
Any experimentation with infrared?
As a matter of fact, yes. We don't have any slides to cover that in this presentation. However, we've been working with FLIR, the thermal imaging camera maker, and they've been very gracious to support us along the way. And we've had several opportunities to fly public safety training missions and some other functions using the FLIR thermal imaging camera, and it's been very, very successful. So that's something we're continuing to experiment with.
Whatever they're providing you with, what do those weigh approximately?
Oh, they're really light, a few ounces.
Really?
It's a military model, so it doesn't weigh anything.
Yeah.
Yeah, we always get asked. It's the Tau 640 high refresh rate, which is it's 640 by 512 pixels.
They call it an OEM product, so it's just a raw camera. That's it. No front housing.
Prohibitively expensive.
Yes, for the hobbyist. We didn't go out and buy it. They provided it to us for some strange reason. So anyway, when I key this next slide, it's just going to play a brief segment of the pilot's eye view. So looking through the on-screen display, we're just flying around a local park here. And you'll notice partway through the video, it changes from color, which is the GoPro, to black and white, which is the security camera. This is a different aircraft than this one, but identical setup in that regard. And so I will just sort of talk you through what you're seeing on the screen while that's happening. So here we go. I can switch these while I'm airborne, one to the other. The idea there is twofold. One, we might be operating in low light, but two, if the GoPro runs out of battery, which actually happened to me once in the air, and it wasn't a happy day, I can just switch over to the low light camera and bring the bird home safe. Both cameras feed into a switch. From there, go through the OSD, the on-screen display, and then out to the video transmitter.
But since we're capturing with the video with the GoPro typically on board, there's no OSD display. It's clean video.
So, in fact, capturing the OSD that's kind of a challenge. So, I'll just briefly go over the OSD so you see what we've got here. In the upper right-hand, you see two battery displays there. In the upper right, the one that's half full there is the GoPro's battery. So that actually disappears when you're, when you switch over to the other camera, because that, along with the little movie camera in the upper left, is being put on there by the GoPro. The little empty battery icon is a separate one that comes with the on-screen display. In theory, shows your flight battery, but it's just not a feature I've used. Thus, although I'm airborne, the battery shows empty. In the center there is the running time clock. That's again put on by the GoPro, just minutes and seconds elapsed since the GoPro started recording. Next to that is your battery condition. PKV is the voltage coming off your battery right now, which is sort of your most reliable indicator for how much juice is actually in the battery.
You should be landing about now.
I should be landing about now, but I was young and foolish when I flew this. That is a little low, yeah. This is why don't you talk about the pack voltage and all that?
Well, basically what it is we use lithium polymer batteries, and the pack voltage varies over its life. Essentially what happens is a dead battery is somewhere around 10.5 volts. And a fully charged battery...
Overstating it a little bit.
Okay. Shortly after 10.5 volts, the battery dies. And then as you charge it, the volts goes up essentially. So this is a 3-cell battery. So each cell has a nominal voltage of 3.7 volts. We'll full charge to 4.2 volts. Anything above that, the battery starts degrading and it'll start expanding and having problems like Boeing had recently. But in this case, essentially, so what we have is milliamperage right below that. The battery basically is, let's say, this is probably a 5-amp battery, so we pulled about half, or a little more than half of its available capacity out of there, which the indicator shows.
So yeah, right below that is milliamp hours. That's counting up. That's how many milliamps the aircraft has burned so far. So if you know this is a 5,000 milliamp battery, in vague theory, you could go until that number read 5,000. You never actually get there, but that's just a secondary indicator. On the left side, you see the ladder. That's your airspeed calculated by GPS. On the right side, your altimeter, so I'm 111 feet up. Below that, the compass, again determined, there's not a magnetometer on board, that's determined by GPS, so you have to be moving to get an accurate heading there. Discs right in the middle is distance from home, and over on the left there I've got 10 satellites in view on my GPS and good resolution. This is the basic control system. This is actually the one I use here. And again, like the aircraft, I've sort of given you a general rundown. These will typically have between 4, which is really puny and pathetic, and up to 18 channels, which is unbelievably expensive and powerful.
And channels are the number of things you can do. Essentially, a basic flight control requires a minimum of 4 channels, maybe 5 for a flight control switch. But the more channels you've got, the more features you can add on, the more things you can access on the craft. So whether it's a light array, a drop mechanism, a camera switch, the more channels, the more things you can do.
Thank you. The good ones have rechargeable batteries. The not so good ones you can drop your AA's into, get the rechargeable batteries. Most of them have,
model memory.
You could have more than one model bound to that one controller, and you can push a button and change which model you fly with it. Basically, I'll transmit on 2.4 gigahertz with frequency hopping. So the event we were just at recently, there were probably 25 machines in the air at the same time, everyone using a 2.4 gigahertz radio, and they were all just jumping around to avoid stepping on each other, and everybody flew fine, no problem. So that's a big change from the hobby.
Yeah, historically, if you were on channel 72, and so was somebody else somewhere else, they'd be interfering with your aircraft. And with the new systems, they're completely immune to that.
So they don't have the channel numbers anymore?
Nope, they do not. No more channel numbers.
There are actually 2 modes which these controllers can operate in. Here in the United States, we use what's called Mode 2. And that is your left stick controls your throttle and your aircraft yaw, that is which way the nose points. And the right stick controls pitch and roll. In other places around the world, very weird, they do it another way.
Yeah, they basically reverse those.
Which is strange and demented, and don't worry about it. But if you're ever buying a model, make sure you buy Mode 2, or everyone will laugh at you, I think. And then this is the sort of the last leg of the FPV quadrupod, I don't know what. This is what you have to have on the ground in order to get it. You obviously need to have a video receiver and some means of seeing the video.
Now, goggles are a bit more expensive than little screens are, but either will do. It depends on your personal preference. We like having the whole immersion technology of having the goggles on our head and not being able to see anything but what the craft sees. One thing to look for if you're buying a small TV is make sure that it does not turn blue when you have bad reception. Worst thing you could have is have a little bit of static in your video and have the screen go blank or go blue, essentially, which means you can't see anything at all. Basically, when you purchase them from any hobby place, they'll say, hey, this does not go blue on you. So I have a couple which do, and I can fly them maybe 50 feet or so. More than that, I'm risking it just going blank on me.
Because
analog TV work better?
Analog TV is required. And again, the big thing is if it goes blue or not. There are people who know that, or people who have tested them, because you can take some of the Visios out there will give you static, which is great because you want bad picture, not no picture. And some of the smaller ones from hobby places, it'll say specifically designed for FPV.
No blue screen.
Yeah.
The blue screen is bad.
Or if you're doing something like video cinematography or photography where you're close in, you'd want to see the screen and perhaps attach to your radio and you can see it, a craft in sight.
So basically it's your version of the blue screen of death.
Pretty much, yeah. That's what happens.
Absolutely. And you want to avoid it. The most frequently asked question we get on the internet is, how do I learn how to fly? So we suggest a 4-step process. And again, I did this exactly wrong and paid the price. We've still got a giant box of broken parts in the basement from not having done this correctly. Step 1, go get yourself a simulator. Log 10 to 20 hours on the simulator minimum before you fly a real machine. Virtual parts are a lot cheaper to fix than real ones. And then step 2 is get yourself a little micro flyer. This is the MCX. You also have an opportunity to fly one of these in a few minutes. Which is, as you can see, just a little palm-sized helicopter. It doesn't fly, it's impossible to fly it aggressively. It just sort of floats around, but again, it's an opportunity for you to begin to develop those basic flight skills. This little guy, I suppose if you've had exactly the right day with no wind, you might be able to fly it outdoors. But anything more than, well, even the gentlest breeze is going to carry it away beyond its ability to...
It also depends if you're using the infrared type controller or you're using the,
That's a fair point. We only use actual radio controllers, and this is a petite little thing, and yeah, you can get something like it at the mall for $10 or something, but which looks like it. But this is, in fact, although very small, a fully functional RC aircraft which uses a standard flight controller. So the flight controller we use to control this guy is identical to the flight controller we use to control this guy, and I think that's important because after all, what you're trying to do is build up to flying this guy.
So how many channels is the microflyer receiving?
4. Step 3 is a full-sized aircraft like this one. That's a DJI hexacopter on the screen there. Fly that full-sized, and then step 4 is flying FPV, putting the goggles on, rigging up the video transmitter, and going for it. I'll just briefly touch on these last points. Unfortunately, we already briefly touched on this one. For hobbyists, these are the rules of the air. You can look this up yourself. Thou shalt not fly above 400 feet. Thou shalt not fly within 3 miles of an airport without the permission of the airport manager. And thou shalt not endanger persons or property on the ground, i.e. do not fly over your neighborhood BMW dealership with your little model helicopter. I'll let you figure out how that could go wrong. Other issues to be aware of. Watch out for anti-drone legislation. We're from Oregon, and right now we're fighting a pitched battle against Oregon Senate Bill 71, which would have, in its initial draft, criminalized the mere possession of this object. And we've managed to turn away from that, but this is cropping up all over. There are a lot of legitimate issues concerning privacy and all that sort of stuff. So there's a lot there, but just be careful because the politicians are not always real well informed and come to make some very overgeneralizations. We also strongly recommend you join the Academy of Model Aeronautics, the AMA, and follow their document 550, which is their set of rules governing FPV operations. And finally, we wrote, don't be that guy. And here I'm referring to most recently the guy who apparently flew a quadcopter up to about 1,500 feet upon the approach route to JFK, which we all saw in the news. So, because that thing came within 200 feet of a jetliner, an Alitalia jetliner. All it takes is that one joker to hit that airliner, and all of us are going to pay a terrible price. So move slowly, don't go faster than your skills allow you to. Always be able to control your bird, or at the very least, kill it and get it on the ground, if something goes horribly wrong. Safely on the ground. Don't drop it.
What the rules are in Washington for those?
Washington State?
Yeah.
The rules I just cited, 9157, are federal rules, so they apply globally. And my understanding with regards to anti-drone legislation, and this is only a vague understanding and only, may only be partially true, is that your equivalent to our Senate Bill 71 just got shot down in your legislature. So you are fortunate for that. But keep an eye on them because I'm sure it'll come back. Finally, if I get everyone to give a big round of applause for our sponsors who support us and allow us to do this. Thank you all so much for being here. We're going to take 5 minutes. So that was our presentation at this year's con. We'll look forward to seeing you all next year, and until then, keep watching the skies.
Well, hope you enjoy watching. See you next time.
All right, fly safe.